Now that we can summarize data with numbers, let's explore how to visualize it. Next, frequency distributions and shape, what the data looks like. When you're faced with a mountain of raw data, how do you begin to make sense of it? The first step is often creating a frequency distribution. This is simply a way of organizing your data by counting how many times each value or group of values appears. We can display this in a table, but a histogram often tells a more compelling story. In a histogram, we group data into bins of equal width. The height of each bar then shows the frequency or count of data points that fall into that bin. This visual representation instantly reveals the underlying structure of your data, making it easy to spot the most common values, identify any unusual gaps, and get a feel for the overall pattern. Once we have our histogram, we can analyze its shape. The first characteristic we look for is symmetry. Is the data evenly balanced around the center? Skewness is the measure of this asymmetry. If the histogram has a long tail stretching out to the right, we call this a positive skew. This happens when most of the data is clustered on the left, but a few unusually high values pull the distribution's tail to the right. A classic example is income. Most people earn a moderate income, but a few billionaires create a long right tail. Conversely, if the long tail stretches to the left, it's a negative skew. Here, most values are on the higher end, but a few low outliers pull the tail left. Think about grades on a very easy exam. Most students score high, but a few who didn't study create a long left tail of low scores. Skewness even affects our measures of center. In a positively skewed distribution, the mean is pulled to the right of the median. In a negatively skewed one, it's pulled to the left. Beyond symmetry, we can also examine the peakedness and tailedness of the distribution. Essentially, kurtosis is a measure of your data's outlier risk. So, by putting it all together, we can paint a detailed portrait of our data. The frequency distribution gives us the basic structure. Skewness tells us about its balance and symmetry, and kurtosis warns us about the potential for extreme outliers hiding in the tails.